This lesson is on inverse variation. Inverse variation is defined as a relationship between x and y such that x and y form a constant product. We can write that as k is equal to xy, where k is the constant of variation. Now we also would want to be able to solve that for y, which we could do by dividing both sides by x. That would tell us that y was equal to k divided by or over x. And this is an inverse relationship. Now we use inverse relationships or inverse variation to do things like this. We could say, what if our cost to rent a condominium was $200 per day? And we wanted to break this down and say, how much was it going to cost per person to rent this condominium? So using our formula to the left, we could say that y, the cost, would be equal to $200, our cost per day, divided by the number of people. Therefore, if we had 8 people, for example, using our condominium together, then we would say that y is equal to 200 divided by 8, or y would be equal to $25 per person to rent the condominium for a day. So this is an inverse relationship showing this cost for 8 people. Now obviously, as we look at this relationship, we could continue to have more and more and more people to some limit that could at least theoretically be infinite, but we would never exactly get down to zero. We could approach zero for the cost per person per day, but we could never reach that no matter how many people we did. It would just get closer and closer and closer. That makes this relationship actually a rational function, which is a function that would never reach zero at that time. It has an x in the denominator when we write y equals k over x. So now let's look at a table involving these values. Quick, I'm going to put this up. This is a table representing that same information. One person renting the condominium would be $200 a day. 2 people would cost $100 each, and 4 would be $50. 8, as we computed a minute ago, would be $25. Each of these amounts would continue on down as we got more and more people into our condominium. Now, one thing I want you to notice is this relationship, unlike a direct variation, is different. Let me get rid of these little marks. And one of the things we notice here is that as x gets bigger, y actually gets smaller. That's the inverse relationship in our problem right here. Notice that each time, too, it is a constant product, as we said a minute ago in our definition. 200 times 1 is 200. 2 times 100 is 200. 4 times 50 is 200. And 8 times 25 is 200. This is a constant product, as is defined as part of our inverse variation. So we have to have that constant product. So let's take a look at the kind of problem you might see involving inverse variation. If x varies inversely as y, and again sometimes you will see with y, and y equals 20 when x is 5, what is y when x is 10? Well, the first thing we're going to need to do here is find out our constant of variation, our k. We compute constant of variation by the definition, which is it's a constant product, x times y. And if we find x times y in this case, the ones we know that x is 5, y is 20, and 5 times 20 equals 100. Therefore, k, or our constant of variation, is 100. Our problem didn't ask for k, it asked for y. But that allowed us to compute the k to use in our formula for y. Y is equal to k divided by x, as we found a little bit earlier. Now we know that k is 100, And we're looking for y when our x is 10 this time, so 100 divided by 10 is equal to 10. Therefore, in this problem, whenever x is 10, then our y value will also be 10. Notice that 10 times 10 is 100, which is our constant product, or our constant of variation.